Welcome back to another recorded session of our SD-WAN training. Hope you all are doing good, and let's get started with this session. So in the previous session, we discussed about the data plane operations of our SD-WAN solution, how actually the vantage to vantage communication works by using the overlay and by using the underlay. How does the SD-WAN underlay fabric comes up, and once the LAN side also is configured onto our branches, then how does the branches uses it? With the help of the network segmentation, you can achieve communication between two sites very efficiently, keeping the security of the flow intact with the help of the SD-WAN.
If you enjoyed the content of the video, don't forget to like and share the video and subscribe to our channel.
So there are certain benefits that we discussed about, right? Be it the transport independence, be it the connectivity at any location, be it the underlay abstraction, be it the end-to-end security, single pane of glass, REST API compatibility, a lot of features, out of which we discuss the features and benefits that we get out of the data plane in the Cisco SD-WAN solution. So let's take that journey further. In this video, we will be speaking about the management plane, the control plane, and the orchestration plane, of course. If not in the single video, then I definitely will be breaking up in multiple videos, but let's see how that goes up. So we're going to start our discussion with the management plane. Right, in the previous video we discussed about the data plane, and in this video we will be speaking about the management plane. Now, I've mentioned previously, of course, that the management plane is something which is handled by one of the component of Cisco's SD-WAN solution, that is vManager. Okay, and unlike the data plane is handled by WAN edges, which can be physical devices or which can be virtual devices. Unlike that, the management plane in SD-WAN fabric is completely virtual. There is no physical appliance that is needed to be purchased in the from Cisco in order to implement vManager component in the SD-WAN solution, right? So the network devices of the traditional environment would be managed via the CLI independently, right? Because the control plane, management plane, and data plane would sit locally on every single device. Cisco's SD-WAN, however, introduces vManager, which is basically a network management station. You can call it as a network management station. We can also refer to as NMS. And via this network management station, which is basically going to provide you a single pane of glass, SPOG, to manage the entire SD-WAN solution, right? So the vManager can be used for onboarding and provisioning and policy configuration, right? And even to monitor how your network is actually functioning from one point to other point. Through vManager, you can do almost everything. You can manage the entire fabric from a centralized point of touch, right? Be it troubleshooting, be it monitoring, be it configuration, be it anything that you want to do on your fabric, you can do that from this vManager. So your daily job or your daily activities are something that's going to be performed in the vManager itself. And although the vManager has a rich feature set, if the preference is to communicate with the vManager separately, right, by using some programmatic approach or something, then it also exposes REST API capabilities. How is that possible? For example, you have a controller side. We also spoke about it into the topological view. So let's say you have a vManager there, and then apart from that, you're also going to have some other components. So like vBond is there, and vSmart is there. Now all of these components, right, are going to be exposed towards the transport. So be it iNet and be it MPLS. Let's say connectivity here and connectivity here. And then the iNet possibly will be connected to, let's say, WAN edge 1 and WAN edge 2, having dual transport connectivity. Now, since the vManager is going to manage the WAN edge 1 and WAN edge 2, of course, but how do you communicate with the vManager? So in vManager itself, you can use an admin PC and you can connect with that admin PC with the vManager. Now, because the vManager then have two type of interfacings, right? One interface that communicates actually with the WAN edges and the other controllers, of course, and another interface that communicates with the admin machine. So if you remember when we discussed about the network segmentation, I highlighted that the transport VPN over which the WAN facing interfaces are part of VPN 0 and the management interfaces are part of VPN 512. So due to this behavior, or since that behavior is over here, if let's say we are using Ethernet 0 as a port on our vManager and Ethernet 1 as another port, this Ethernet 0 is going to be part of VPN number 0 and the Ethernet 1 will be part of VPN number 512 as it is specifically being used for out-of-band management, right? And then how do you communicate then with that particular vManager? So definitely you will be creating some subnet. Let's say if 10.1.1.0/30 is the subnet, .1 over here, .2 over here. Then you would go onto your admin browser and you can use any sort of browser, maybe Chrome, maybe Safari, or maybe Firefox. And in these, you can simply type https:// the IP address of the VPN 512 interface, assuming that's 10.1.1.1, and this will give you the GUI access of your vManager. That's you can say a major way of do that. But like I said, though vManager has a rich feature set, if the preference is to interface with the vManager by using programmatic features or via using REST API, then you can use Python or you can use tools like Postman in order to send REST API queries directly onto the vManager's Ethernet 1 interface, which is part of VPN 512. That is also possible very much, right? So this is how you interface with vManager for managing all your fabric. Post that, so the vManager is also highly scalable depending on the needs of the environment, right? You can either deploy your vManager in a standalone mode or you can deploy it in the cluster mode. If you deploy, or deployment methods, when you speak about that, so you can deploy it in standalone mode, or you can deploy it in cluster mode. In standalone mode, one vManager can manage up to 2000 WAN edge devices, and that's a huge capacity, right? One vManager can manage up to 2000 WAN edge devices in a single production environment, okay? And if you cluster it, which is minimum 3 vManagers, then that becomes 6000 WAN edges. And you can increase the size of your cluster also to 5 and to 7 and to 9 to 11 and so on. Okay, I've seen a production environment with 11 vManagers deployed, geographically dispersed across various regions, also making high availability possible, on-prem, on-cloud combinations, which was managing around I think 20,000 managers or so. That was the scenario over there. But you can say that, and you cannot deploy it in 3 or 4 vManagers, 6 vManagers. So odd numbers of vManagers needs to be deployed. Even numbers cannot be deployed to avoid split brain scenarios, right? That's the deployment method that you can follow. And like I said, One vManager manages 2000 managers, three vManagers can manage up to 6000. If you deploy five vManagers, it can manage up to 10,000 managers over there, right? So that's the deployment methods. Now, how does it generally work? So all the configurations for the SD-WAN fabric should be performed in the vManager itself in order to maintain consistency and scalability in your network. And when you speak about that, how do you deploy this then? Or how does the configuration gets pushed onto the VANages? So every VANage will be forming up an overlay tunnel after the underlay is ensured, that the underlay connectivity is provided. Each VANage will form a single management plane connection to vManager, and that if the device has multiple transports available, only one will be used for management purposes. What does that mean? For example, VANage 1 can form a tunnel by using the INET and also can form the tunnel by using the MPLS. So is it going to form two management plane connection? No, it will only form one. And is there any priority that's going to be set, that whether to form the control connection or management plane connection only with MPLS or only via INET? By default, there is no such priority. Whatever comes first, the VANage will form a tunnel by using INET also and by using MPLS also. There are no specific performance requirements expected from the transport, because the vManager is just going to track certain reachability tests. If the reachability is up and running for the VANage, that's all that it requires. It doesn't need to send heavy load of traffic onto that particular tunnel. So performance or high performance is not really required to maintain that particular management plane connection. Okay. And if there is a cluster in place, then the control connections will get load balanced across the cluster nodes. We'll speak about the clustering and high availability part later though. But yeah, so the tunnels which are going to be formed between VANage and vManager are going to be DTLS tunnels, which stands for Datagram Transport Layer Security. Okay, it's going to be DTLS tunnels, Datagram Transport Layer Security, and you cannot change that. So there are mostly two types of tunnels that we expect out of our fabric. Number one is control connections. Right, which are generally between vEdge to controllers. Two ways, right? And other type of tunnels are data connections, which are between vEdge to vEdge. So the control connections are always going to be DTLS tunnels, right? And data connections are always going to be IPsec. Although you have options, you can also form GRE tunnels, but we are going to form IPsec tunnels over here. So be it the VANage forming tunnel with vManager, VANage forming tunnel with vBond, VANage forming tunnel with vSmart, all of these mostly are going to be DTLS tunnels. You have an option though, that if you want to form a tunnel with vSmart, only with the vSmart, you can make that particular tunnel DTLS or TLS, which means UDP or TCP. That's the major difference between both of them. Okay, but you do not have the choice with the vManager or vBond. These are mandatorily going to be DTLS tunnels. Okay, so that's how we segregate connection types. And both of these are overlay. The underlay reachability must be ensured for forming up these tunnels. And whenever there is any configuration that gets placed, so you sit over here, you are only interacting with vManager. vManager have control over VANage 1, VANage 2. Any configuration that needs to be pushed, you inform it to vManager. vManager will take care of forwarding that configuration out to the other devices. How does it do that? What protocol does it use? We'll speak about that in the coming sessions. So that's your management plane generally. Okay. As a summary, you can say that the vManager is going to be your single pane of glass where you will be managing the entire fabric, be it configuring something onto the fabric, be it monitoring the fabric, be it troubleshooting the fabric, whatever job you want to do on your fabric, you can do it from a centralized point of touch where the vManager can be deployed in the on-prem deployment method, or it can also be deployed as on cloud. So that's my bit about management plane. I hope you understand how management plane works in SD-WAN fabric. Thank you so much for watching, and in the next one we will take care about the control plane. Thanks. Take care. I'll see you in the next one. Bye-bye.